Hello, class.
Good afternoon.
How y'all doing?
Hello, Mr. Sylvester.
All right, all right. Yeah, I got to still grade y'all programs, class. I had a long week, I tell you, last week. But I'm a grader. Anybody with any questions? Let's see. Questions?
Yeah, so those programs,
Uh-huh.
was I missing something, or were they really just that simple?
Right. Just using the loop. Like I say, you use 2 of the 3. We went over. It's simple. And like I
Okay.
say, it could be something that you, how would I say, that you are gonna be good at loops. You know what I'm saying? Some people might have had a little difficulty understanding, the iteration and whatever and whatnot,
Okay.
as opposed to you. Yeah, they were because it wasn't that hard. Like I say, you got a loop to do whatever, and then another loop to do whatever. Right. Yeah.
Gotcha. I was just making sure because I didn't have any problem with the other two, and they seem kind of
And
like I
right, but
did
they're
something wrong
always
there because it was
basically
too
the
easy.
same, right? But you have
Yeah.
to just swap out the different type loops, right?
Yeah.
Right.
Yeah, that's what I emailed you about. I was using a while when I should have been using a do while.
Oh, okay. I don't even think I saw your email, man. I don't think I even looked at it.
But you responded.
Oh, yeah. Oh, but see, that was what? That was
like a week ago.
Yeah. And like I said, what I do, I don't try to give you the answer, but I try to lead you into the answer like, oh, okay. Oh, all right, now I got it. Right. Because I don't want to just tell you, oh, just do this, and you do it, and you don't get the reasoning behind it. Right. Okay. So this class, hold on right quick, class. Let me answer this right quick. Hello? What's up, man? Okay, I'm back, class. Now, the next chapter we dealing with is and class, go ahead on and put your names in the chat. You know, go ahead on and put your name so I can have you in for the role. Functions. All right. Anybody read up on functions? Because that's going to be our next chapter, functions, and we'll look at it. Let me open visual, so we'll see exactly how that works. Now, when we writing code with functions allows us to break up our code so that we can, modularize our program, right? And it somehow makes it a little bit better to organize and read, right? So let's look at our notes. Let me share my screen right quick. All right. Anybody with any questions before we get started? Share. All right. Okay. So we're dealing with functions. Okay, let me move this to the side. There you go. In the screens. All right. So functions, all right? So what it tells us about functions, let me change this too. Where's that at? Display. All right. So it tells us program may be broken into manageable functions, all right? Broken down into pieces of lines of code to where it can execute and then maybe return to a particular section of your program. So now, a function is a collection of statements that performs a specific task, all right? Now, it tells us so far you have experienced functions in two ways, okay? One, you have created a function, which is the main function. The main function is needed in any and all C++ programs, all right? So if you use the main function, that's one function, but we're going to write other functions that are going to have lines of code in it. The second way we have used functions is that we have actually called or used commands that have instructions that are built in to the compiler that we actually retrieve and access to do something. We've used a power function, even a cout function. Those are functions also because other code is tied into it to make it do what it does do, right? What it do. So now, in this chapter, you will learn how to create your own function that can be used like libraries. Now, there's many different ways you can use functions, all right? You can write program with functions where you're not passing values or variables, all right? There are programs that can be written to where you are returning a value. There's programs that can be written to where you passing an array or whatnot. So you can do it in various ways. So let's see here, I'll just kind of show you here what they're talking about when they're talking about function. Here's the way we normally been writing programs, step by step by step, and minus the loops and whatnot. Step by step instructions, start here, and we end here. Now we're going to start trying to write code to where you may have the first 5 or 6 statements, or maybe not even that, starting at the 4th statement through the whatever statement is going to be in the main. The 1st through 4th will be in the main, and then in the main you'll have a call function that's going to call these statements from this function, another section of statements that'll be called from here, and then another set of statements that'll be called from here, all to do what? The exact same thing. But what happens is your logic becomes a little more clearer in an abstract way as to what you're doing. Give you an example. You might have like declaration statements. Then you might have a call to call this function. And this might be a function to get the data. Then you have the next function, next statement, next function call that gonna consist of all these statements. That might be to calculate something of those input data or whatever. So you'd have statements, then a get function, then a calc function, and this might be a function to print, and that didn't mean last three. So what you end up having is maybe declaration statements, a get, a calculate, and a print. So you would see that in the main, but you would not see the actual statements in the main of what those functions is actually doing. But you have a general or abstract knowledge of what they're doing. So it kind of makes your visual of the program a little bit better. All right. So it's another reason to write functions is that they simplify programs. All right. If a specific task is performed in several places, all right, in the program, a function can be written once to perform that task and then be executed anytime it is needed. And what that means is, like, say, if I needed to print, I could print at the very beginning. I could call this function. I could print again. I could call this function and print again. And now I'm executing those print statements multiple times without having to try to rewrite statements over and over or duplicate statements in my program. Now, defining and calling functions. All right. So you have to define a function or like kind of give it its definition, all right, as to what it is to be doing, all right. And then you also have to call a function, all right. Now, another aspect to functions could be the prototype, but it all depends on how you set up the program. But let's look at this. A function call is a statement that causes a function to execute. A function definition contains the statements that make up a function. Now, you've been writing programs. Let me get back here. You've been writing programs to where you were using a header file, and your header file had a function in it. Correct. So you kind of hopefully have gotten familiarized with somewhat with functions, all right? So hopefully this will come up and I'll show you something. Let's see what happened. All right, so what I'll do here is head here is a header file. But if we look at head, in head we have a function. Function header, open curly brace, close curly brace, and this is the body. All right, so if I go back to my source, here is where I'm actually loading the header file. So it's a little different, but here is where, I don't even have it here, where I would do a head. And that's when I would call that information that's over here, that's in here, to be printed. All right. So hold on a minute, class. Let me see something. I need to go on my nose. Let me see. Hold a minute. Okay. All right, hold on right quick. All right, my nose was running a little, so. All right, so let's look at a program. I'm gonna remove all this to kind of show you. Control A, Control X. Let's do it. Okay, so and let's say you. This is the main function we talked about, and everybody have created a program using the main function. So now, if we wanted a function, say we wanted to write a function to do something, say just reading some numbers, all right? So normally I can, I'll have to do it here, so could make it global, because I'll tell you about the other part where it's local. All right, I say int x equals 3, y. I'll just say int x, y, in total. All right. Now, so I have these variables. So here I would say void compute. All right. So now I'm going to define this function. But first of all, I need to set up a prototype for that function. Void compute. I did computer. I'll say computer, open, close, semicolon. So now, so I have a function called computer, all right? And then I had it as computer. Then I can say cout say enter a value. Okay. I enter a value, semicolon. Then I'll say cn x. And then cout enter value. Now, cn y. And then I could say down here, total equal x plus y. So I'm just calculating total. And then in my main function, I'm going to output total. Why didn't know? I see why. All right, the total of, I'll say x and y is now, and then I'll put our total. All right, so that's in the main program. So I wrote a program to where, and I'm not finished yet though. Wait. Where's X? Okay, string. All right. So here I have to call my function. So now, let me open this wide. So here, so I have a program where why it's not all the way to the right. Okay, so here we have a program where I have a main function. This is my main function. My main function says call computer. Where's computer? Computer is down here. What's going on in computer? I'm entering the value. I'm entering the second value. Then I'm totaling the value, right? But then I'm coming back to main. right after what happens when you execute a call and you go to a function, it returns to the next executable state or the next statement, and then it's going to perform X, the total of X and Y is, and then it's going to print out the total. All right. So, and what happened here? This is the prototype. Void computer with no arguments. Void computer, no arguments, and there's the definition. So if I run this, if I debug this, oh, it's okay, it's there already. All right, so notice what happened. It said enter an integer value. Where did that come from? That came from what? This function here. So what happened? It executed it declared these variables, and then it started with the main, and it said, oh, here's a function. Function called what? Computer. Computer is declared. It actually have like a declaration. Okay, so now where's the definition? Okay, actually what it is to do is down here. So what to do? Output this. So let's input a value. Say we input, if I can get it while I want. I'll input 12, hit enter. I didn't tab over, but it says enter second value. Second value, I enter 10. So now when I enter 10 and hit enter, it's going to add the value, return to the next statement, and output total of X, which is 12, plus Y, which is 10, equals total, which is 22. So see how I wrote code, but I split that code so it'll execute. Now, I can do the same thing by just, if I copy this out here, I could say, I could copy this. I'm gonna leave my function. I'm gonna copy this. What else? What done happened here? Undo. All right. So what's happening? All right, here we go. So I'm gonna right click, I'm gonna copy this. All right, I'm gonna copy this, and I'm gonna comment this out. Because I don't want to call it this time. I'm gonna have it all in the same function in the main. So everything is in the main. So when I run it this time, it's not gonna call this, it's gonna execute this, and execute this. This is the way we would normally write our programs. So if I run it, I'm gonna get the exact same result. Let me close this up so we can see. All right. So we run it, debug it. All right. Value, I'll say 8 and 2. See? Same thing, same exact results, but what? Now it's all in the main function. But when you saw when I had it in this fashion, let me do one more undo. In this fashion, computer. What's going on here? I don't know what actually was going on. I could put a comment saying retrieve and add data, so I'd have a somewhat knowledge of what it's doing, but then I can go to the actual function and see what is actually happening. So that's how functions work. And normally what some companies, what they'll do, they'll have specifications as to how many lines, the most number of lines that can be in a function, or either sometimes the least number of lines that can be in a function, all right? Because they may not want you to just write functions with just one line of code in it, or they might not want you to write a function with 50 or more lines of code in it. You need to break it down further with much more functions, all right? So this is how functions work. Now, this is just the general idea of functions. Having it where you're calling the function name and going executing the function and then returning back to the call function, the function that actually called that function. All right, anybody with questions so far? Any questions? All right, All right. So look here. If we look at our main function, we have a return type. If this says void, it means there's no return type. If it says int, you're going to have return and either some value or some variable of that data type. Okay. Main would be the name of the function, and you have the parentheses, which enclose the arguments that you are passing. But if you notice, most time when we do our main, we are not passing any arguments. All right. But in our other function, we're going to see how we can pass arguments. Now, then within the curly braces defines what that program is to be doing, right? So that's the makeup of a function, all right? So now, void, okay? When you have void, all right, you already know that a function can return a value, all right? The main function, because we use the main, returns 0, all right? The main function in all of the programs you've seen in this book, all right, are declared with a return, declared to return an end value to the operating system, letting it know that execution has, it went through everything and completed all the statements successfully. That's what it actually means, right? It isn't necessary for all functions to return a value, all right? However, okay, some functions simply perform one or more statement, then follows a termination. Now, calling a function, we did the call, right? Now, this is the actual setting up the prototype. Okay, what's the name of the function? Display message. Okay, where did it call it? In the main function, it calls display message. Now, if you look at this program, in this program, they don't have a function prototype, but rather they define the function at the beginning of the program, which is good. You know, you can do that. The only problem I would say in doing it this way is many times when you do it this way, just like when you're looking at the logic of your program, you cannot have a function that's dependent on a value that's in another function below it. Because if I'm declaring something, if I'm using something in a function and it's above the function where the value is being determined to be used and getting the value, then it'll be out of whack, and then you may get wrong data, or either the program won't work because it's saying, oh, this is an unknown value. So if you put your function before your main, they will have to be logically in logical order, right? They can't just be, oh, I put this one first. No, it have to be in the way that the variables within them that are used are defined before they use them and whatnot. All right. So I'll give you an example of what I'm saying about it can be before it. So I could take this function here. All right. I'll take these spaces out. All right. So I could take this function here. All right. Take it out. I'm going to cut it. All right. I could cut it. And what I'm going to do, see where I have this function prototype? I could paste it here, and I don't need the prototype. Right? So I don't need the prototype. I just paste it here. And now that's like kind of declaring this is this function, and this is what it's doing. So now it knows that. All right. But I would say, let's see, will it work? No, it will not work. It shouldn't work. But let's run it. Because remember, look, I got int x, y, and z. But in this function, I'm saying c and x, c and y, and total is, not total. And total is equal to x plus y plus z. So let's run it so I could show you. So it got to be in that logical order. I should get errors. See, I've gotten the errors. Now, I don't want to debug. I don't want to. So look what happened. X is not defined. Y is not defined. Total is not defined. All right? And then here, it said X and Y are undeclared. These are undeclared. Now, look what happened. What happened is I put this function here, and I'm saying C and X. What is X? I don't know. I know when I get here, See, and y, what is y? I don't know, but I know when I get here. So I would have to take this statement, all right? Let's catch it here. I'd have to take this statement and move it before, let me take this up. I'd have to move it before this. So now what? Now I've introduced X, I've introduced Y, and I've introduced total as integers. So when it looks at this defined function, oh, I know what X is. Oh, I know what Y is. Oh, I know what total is, right? I may not know the values that's gonna be inputted, but I know that did it. So now, and I have my call here. My call will call this function and print it out. So let's run it. See, 3 and 9 is 12. So that's all I'm saying. But if you just do the prototype, it's like I'm just declaring all this to be this. And now whenever I use it, I'll be able to use it. So it's all up to you as to how you do it. It's all in programmer style, all right? Programmer style, all right? So like I say, when you do it this way, you're just saying what? I have a function, okay? Now I have some variables, but then now is where I'm using those variables, so it's okay because what? I just declare all my variables at this point, all right? I'm not using them or anything. So that's the difference, right? That's the difference. All right. Back to the notes. All right. So like I say, you can have your function at the beginning, but when you're dealing with variables, you're gonna have to make sure if I declare something right before the main, it better be, if it's in here, I have to put it up here so it'll be declared. So what happens in this program, I say main, output hello from main. Then it goes to, or it's calling display message. It goes up here and says, okay, hello from the function display message. And then it returns back to the call function, which is the main, to the very next statement, see out back in function main again. And that's the output that's got here. All right. Now, that's the general idea of writing a function. It does get complicated, all right? It does get a little complicated, all right? So here it tells us this is the function header, this is the function call. Function call, you're gonna have your semicolon at the end. Function header, you're gonna have your curly braces and define what it is. So you're not gonna have a semicolon at the end, all right? And then you're gonna have your return type at the beginning of your function header. On your call, you won't, okay? Now, let's look further down. Let's look at what happened. Same thing we talked about. It executes. Oh, call this. It goes up here, executes. Oh, I'm at the end. Come back and return and see out that and return 0 and it's finished. All right, so that just shows you the flow of the logic. All right, so this is basically the same thing, okay? Is here, out this, but look what happens here. I have hello from the function display message. If I wanted to output this 5 times, all I needed to do is put it in a loop. I ain't had to write what? See out, hello, whatever. See out, hello, whatever. See out, hello, whatever. See out, hello, whatever. So see how you can actually execute a function multiple times. So watch, let me see if it's set up where I can do that. So here, I have this function. If I do this, not X, yeah, I could do X. I equals, yeah. All right, so what I'm gonna do here, I wanna execute this 5 times, but I don't want to keep writing computer, and see how this, that. So I'll do this, all right? But what I need to do in order to make my program run right, I need to do something like, because each time I want my total to go back to 0. So that's just something I know I have to do because of what? Because of mathematics. So now, let's run the program. So what's going to happen here is, in the main, it's going to fall into this loop. I equals 0, set total to 0, all right? Then call computer. Call computer, return here. Okay, go back here, I is 1. Total 0, call computer. Go down here, output whatever. On and on. So let's run it. Okay, and our value, 3 and 9. Okay, see it did it one time, 2 and 8. Okay, 4 and 5. That's 4. No, that's 4. Let's see, 1, 2, 3, 4. Yeah, there's a 5th one. So you see what happened? I was able to, using a loop, allow it to call this function 5 separate times. I didn't have to try to what? Rewrite this code 5 different times. So you see how putting your information in a function, and like I said, I could have had it all in here too with the if logic, but it makes it more cleaner when I just call that function to do this. You understand? Rather than have all that information in here. So all you're doing is just breaking down your program into smaller pieces so it's more easier to understand, easier to debug, easier to even update, because you're not looking at filtering through a whole lot of code, a whole lot of levels of ifs or whatever. And so it just makes it that much easier, right? Any questions? Any questions? Now, let's go down back to the notes, all right? So see here, this one, what it did this display 5 times by just simply adding this line here, all right? So now it's showing you how you can have more than one loop. My fault. More than one function, all right? They have a function 1 defined here, all right? Well, called first. Of the function called second, and then the main. And what happened? If we look at the main function, because the main function will always be the first function executed, right? Now you can call a function and go to and execute it, but the first function will be called from the main. So it's going to output, I am starting a function in function main. Then it's calling first. Where's first? Here's first. I am now inside function first. And then what? Oh, I'm in and go back into the program. I return to the very next line of the line that was used or called. Okay? So it calls second. What is second? I am now in the function second. Okay, when it gets it complete, and then it returns, and then says back in function main again. Right? So that's the output, and we return 0 and it quits. All right? So if we were to do that, same difference, I could do something like this, and then I can do void greeting. Right? If I could tell you. All right, void greeting. Now, what my greeting could be anything. All right, greeting could say void. All right, and then in here I could say something like see out. All right, I'll do something like this. See our great job. I'll do /n /n/t. That's wrong. /n/t, and then I'll do /n. All right, so I have this. So now I could run this and I won't get errors, but it will not print this, right? It will not print this until I tell it to call it, all right? Now, watch this. I can call it from here in the main after this, all right? Or I could call it when I get to the end of this function. Let's do it here first, all right? So I'll do greetings, all right? So is it greeting, no S. All right, greeting, all right, greeting. So this is my prototype, this is my call, and this is my definition. So let's run this. And I'll change this to 3. All right, so debug this. All right, inner value 102. See, great job, 203. See, it have great job, right? All right, and it ended. So notice what? Great job was executed every time. Now, I could do the same thing by taking greetings out of here. Well, let's look and see what it actually, how the program flowed, right? The way the program flowed is, all right, I got my prototype here defined and declaring my variables. Now here in my main function, all right, I got a for loop. What I'm doing in this for loop, everything from here to here. So if we look at it, total equals 0. Computer, call computer. What I'm doing, enter a value, the first value, I enter a value, enter the second value, enter the second value. Then it adds them together, but then, I'm at the end, so I return back to the very next statement. And so this statement said call greeting. Call greeting, I want to output great job. Return back where? To the call program or function. And then what? Output the total, whatever. All right. Now, so it's a little different. So you see what happened. But I could take this out. I could cut this. And I could paste this at the end of this program, this function here. So all of a sudden now, I should get the same results. But what happens now is, for this for loop, I'll set total to 0. Our call computer is going to execute this. But before it leaves computer, it's going to call greeting and execute this. And then return where, class? Once I call greeting from computer, all right, execute this and output this, where does it return? It's going to return back to computer, but I'm at the last statement, so I'm at the end. Okay, now what function called computer? Main. So I'll go back to the main, to the very next statement, and this is the statement. It execute this, and it start the loop all over again. So even though I changed the logic of it, it's still going to run the exact same way, because before I call computer, then I call greetings, all right, then I executed this. But this time I'm calling greetings, and then calling computer, and then going to computer, I'm calling greetings, returning back to computer, which return back to the main and execute this line. So let's run it. All right, value. See, great job. Give me my value, my results. Great job. Give me my results. All right. And I put a 3W. All right, great job. And give me my results. So you understand what happened? It actually did the exact same thing, but we know that this time it's not going back to the main after it does a greeting it's going, after it does computer, it's going to greetings and then returning back to computer and then returning back to the main. So that's how functions work. It always returns to the calling function. All right. So now, let's go back to our notes. All right. All right. So this shows what? It says int main, because we always execute the main first. See out this statement. Then what? Oh, call first. It calls first, it executes within first, get to the end, return back. Then the very next statement, okay, oh, I'm calling second. It calls second, executes second. I am now inside the function second. Oh, I'm at the very end, and then I return back here, and I'm finished. All right? So that's all that's showing. Okay? So, and basically, same thing here, but they got deeper and deeper, and which is what I just showed you. From deep, you call in the function deeper, which takes you in the here. Then you get to the end and you return back to the next line. It's gonna see out you're back, and then what function called deep? Main. So you're going back to the main and output back in function, and then return 0 returns in back here, saying that the program has completed. All right. So that's how functions work. So, and then it just showed you how it went back and forth. Now, the function prototypes, and that's what I showed you. A function prototype eliminates the need to place a function definition before all calls to a function, all right? So what you do, just do your prototype and then add all your programs all your functions beneath the main, all right? Before the compiler encounters a call to a particular function, it must already know the function's return type, right? The number of parameters it used and the type of each parameter, all right? So we'll look at that in a few. Now, one way, and like I say, that's why I always use the prototype. One way to ensure that the compiler has this information in it, it is to place a function definition before all calls that to that function, right? This was the approach taken in 6.1 and 6.2. So that 1, 2, 2, 3, and 4. Another method is to declare the function with and that's how I do it. Well, function prototype. Here's a prototype for a display message function. All right. So you do the void, because that's the return type, and then the name. All right, with no arguments because we didn't have any arguments. All right, the prototypes look similar to the function header, except there's a semicolon at the end, all right, of the function prototype. The statement above tells the compiler that the function display message has a void return type, which means it does not return a value, and uses no parameters, which is the open curly brace. All right? Function prototypes are known as function declaration. So you actually declare the function, like I told you before, and then to be used, and then at the bottom you do the definition. All right? You must place either the function definition or either the function prototype ahead of all calls in the function, right? Otherwise, the program will not complete. All right. So looking at this, you got first, you got second, but where's main? This is main. But if you do it in this fashion, remember the first one had first and second defined before the main, so you didn't need function prototypes. But here, you got the function definition for first at the bottom and for second beneath the code. So now you need to what? Set your function prototypes. All right. So like if you write the code, you should know whether or not you're returning values. You should know whether or not you're passing values to the other function. All right? And like I say, normally you get the exact same results. All right. Sending data into a function. Now what we're going to do, we're going to pass some data to a function. All right? So in order to do that, we have to have a parameter list, right? So now let's do this, and I'll show you the importance of it. What we'll do, we got compute, right? But what we'll do this time, how would I do it? Because I want to do just one value. I don't want you to be confused. All right. So let's do this. We'll do something like this. Take this up. I'll take all this up. I'm gonna still have to define it. All right. So what I'll do something like this. I'll take this out and show you the difference. All right. Take that out. Take this out. All right. I'll call this compute. All right. So now, at this time, I'm going to declare a variable to be local to the main. When I had X, Y, and Z out here, they were global. They could be used anywhere, no problem. So I'll just say int number, all right? Then I take the for off because I don't want to confuse you with that. Delete that. All right, I could delete. Delete that. Okay. So I have int number. So I'll say cout for the type. Okay. Enter a number. Now, so enter a number, cout, or cn. So I'm gonna enter a number, but before I enter that number, when I enter the number, I want to call compute. All right, I'm gonna call compute. I'll say void. And this time, I want to take that number that I inputted in this main function, all right, and the variable is local to main. I want to double it in the compute function, all right? Okay. Now, so what I'll do is, not void, I'll call compute, but then I'm gonna pass number. Okay. But in my prototype, I shouldn't put number. I should put the data type of the variable that I'm going to be passing. I'm going to say int, right? So what's going to happen, what this says is, I'm going to be using a function called compute, but I'm going to pass in its arguments an integer, all right, when I call it. So here, you call in that function, and number is known in here, and you're passing number to that function, all right? So what I'll do, I'll cut this out. And what I'm gonna do, I'm gonna say void compute. Right. But void compute, my function definition and my function definition and my prototype, the heading should be the same. And when I say the same, void, it should be void. Name, compute. But then it tells me that I'm gonna be passing an integer. So now I need to say, tell it an int and give it a variable name that I wanna use in this particular function. So I'll just say num, all right? Void num. Then I could say num, if I could type, times equals 2. Right. So all I'm doing is doubling up what num is. All right. So now, then I can see out num, which is what I had. I think I had him up there. All right. I don't want this. I could say what? All right. So now I can output num. All right. So I have that. What else? Oh. Double quote. Now, so I have this information. Why would that be? Oh, because I took out the if. So now, in a semicolon. So class, look at this. And no matter how large the list is, I'm passing only one int. If I was passing 2, I'd have int, comma, int. If I was passing an int, and a double, it would be an int, comma, int, comma, double. Right? But look, I'm passing one int. Okay, I'm calling. Should be what? An int. Num is an int. So void compute. Oh, I'm passing an int. Okay, what's the name that's going to be used in this function? It's going to be num. All right. So now, why did I get an error here? Oh, because my double quote. All right. So now, if you look at it, the value that was read into number. When I call this function, I'm passing the value of number into this int value in compute called num. So when I do a num times 2, num times equal 2, it's going to double num and going to output num. Right? But a lot is happening here. Like I said, just getting started. You got a function prototype saying that I'm passing an int when it's called. Here's my call saying what? I'm going to take number, which is going to be inputted from the keyboard, and take that value, and I'm going to store it in num. And then I'm going to double it and print it out. So let's run it. Okay, it's going to ask me for a number. It should. All right, input a number. I'll say 50. All right. Let's see what happened. The double of num is 100. So, like I say, what it did, we entered 50, but like I said, it said I'm going to pass an int. So input a number, I inputted 50 here. It took 50 and it passed 50 to num, and then it executed this statement here, num time equal 2, and then it outputted num. All right? Everybody see that? And like I say, programs can be, you take a simple program and set specifications like this on it, and it can give you some headings, right? So now, say I wanted to pass 2 numbers. So I could do int number or number 1, comma number 2, right? So here, when I read it, I'm gonna read it num1 and number 2, right? And I just use one input state, all right? One input line. Right. So now, enter 2 numbers. All right, so enter 2 numbers, and then I need to modify this program. This should be number 1. But I said I want to pass 2 numbers. So int, all right? That's my prototype. When I look at this, it says, oh, okay, I'm gonna be using a function called compute, but I'm gonna be passing along, when I call it, I'm gonna be passing 2 integers. So I look at this, compute, but I'm calling it, but I'm only passing one integer. What's the other integer? Number 2. Now, I got that straight on my call, but now my definition still has what? One int that is using. So I need to do another int and another variable, all right? So now, and then now I need to what? I need to put a total. Now I could do something like this. I could pass it. All right, so now I could say total is equal to num1 plus num2, all right? So now here I want to print out the total. All right, so I'm printing out total. So what? I have 2 integer values that I'm going to be passing. Okay, what 2 integer values? This is my call. I'm going to pass num1 and I'm going to pass num2. Okay, I'm going to pass num1 and num2 to what? Num1 in number 1 and number 2. But then I'm going to pass number 1 and number 2 into a function called compute to number 1 and then number 2. All right, so now you got to remember though, the order in which they're listed in the call here is the order in which they'll be sent. So it's gonna send number 1 and then number 2 in that order. So number 1 is number 1, number 2 is number 2. All right. So to execute it, debug, and you're gonna actually ask me for the value and the 2 values. So 3 and 1. See? 3 and 1 is 4. Now, you might say, oh, well, that program just added 2 numbers, but it's doing more than that. It's using a function to pass local variables to a function to be calculated. Okay? There's a difference. Because you can write the whole little program that maybe 5 or 6 lines without a function and it'll work. But that's not what we going over. We going over functions, all right? We going over functions. And like I say, you can pass anything, a string, a char, an int, all that. It doesn't matter. Now, let's go back to the notes and see what else they're talking about. So, it passed a concrete value. So when it say display 5 and pass 5, it's sending 5, the value 5. All right. But normally when you write code, you passing variables that values that's associated with a variable. Because to write it in the fashion that it is with the constant, I mean it'll never change. But to look at it and see how it works would help. Now look what it says here. Display value in 5. So display value is that call function, our call statement. When you call display value and you pass that int a parameter, you're passing it into display value to a variable called NUM. All right? So that's what it's saying. When we, in our program right here, when we pass num1, num1 was passed, or number 1 passed to num1. Here, number 2 was passed to num2. All right? All right. Now, so looking at this, notice they got display val is passing 5, display val is passing 10. Display val is passing 2, display val is passing 16. So this is almost like saying I'm gonna execute that display val function 4 different times, but every time I display it, I'm actually passing the number 5 the first time, 10 the second time, 2 the next time, and 16 the last time. See, so see what happened. So that's what that's saying. Now, see, look, when you pass in multiple, you just separate it integer. So looking at this, it's like, okay, I got a function called show sum. That function is void, which means nothing is being returned back to the call function. And I'm passing 1, 2, 3 integer values. Okay? Passing 3 values. So let's look at this program. You got your main function. Everything starts at the main. Remember that. So I got int, value 1, value 2, value 3. So here it says, and it's basically kind of like our little program. Enter 3 integers, all right, and I will display. So what happens is I will display sum, right? Now, cin, val 1, val 2, val 3. So we know that we can input and hit enter, input and hit enter, input and hit enter. But the program is written also to where you can put the value, space, value, space, value, and then hit enter, and it's going to accept everything, all right? So now, we're going to call the function. So now we're calling the function show sum, and we are passing value 1, value 2 into value 2, and value 3 into value 3. All right, but, all right, it's passing these values, but look, show sum is passing value 1 into what? Num1, it's passing value 2 into num2, and it's passing value 3 into num3. All right, and that will allow you to output, let's see, you return back where? To here, wait. Oh no, and then you're gonna output whatever this plus this plus this is, and it's gonna give you that output. All right. So that's the functions, right? And in your show function, if you notice, like I say, now some students they'll use the same variable names, which is fine. All right, in your calling function, but you can use different variable names. Example, look in our program. We had number 1, number 2. We went to our compute call. We are passing number 1, number 2, and we passing it to here to where into num1 and num2 and calculating the total. Now let's say we change this to number 1, number 2, all right? So what happens is now I have the same name in my call when I'm inputting and then calling it. And then when I get to this function, I'm passing them into the exact same name. But the names may be the same, the scope of those variable names are different, right? So the scope of this variable name can only be used in that function. The scope of these variables can only be used in this. But what happens, we are putting here, so that way it ain't interfering with anything. All right. So if we run it, so now let's run the program because I didn't run it with the same values. So debug and asking for 2 values, 20 and 4. See? Same results. So I'm telling you, functions are good, and but they can get complicated. All right. But we're going over some of the different ways you can write your functions, all right? So that you can accomplish what you need to accomplish in the manner that's being asked of you, all right? So let's look back here. We did down. Wait, where's my cursor? All right. So, and all it's just saying is that in this show function, you have to give a data type and the variable name, data type, variable name, data type, variable name. And it should match your prototype here, what? Int. You don't have to give a variable, right? But in your definition, you have to give int, you got int, but each one of them have a variable. Have to do that. So now it tells us that each parameter variable in a parameter have a data type listed before name. That's when you're doing the definition, right? We said that. Example, a compiler error would occur in the parameter list of the show sum function, where show function were defined as shown in the following. Because what? You have to have int number, comma, int num2, comma, int num3. You can't just say int and then comma, whatever. Because like I said, you could have different data types. You could have int, num1, float, num2, char, num3. So you got to give the data type for each parameter that you're sending. All right? Okay. So now, what it's just showing you here, how whatever value was inputted for value 1 was stored in the number 1. Whatever was input for value 2 was stored in the number 2. Anything stored for number of value 3 was stored in the number 3. Now, this is the thing, class. If I were to reorder these variables, if I took num3 and put here where I had int num3, comma, num2, comma, num1, what would happen is value 1 would go into num3, value 2 would go into num2, and value 3 would go into num1. So in short, what I'm trying to say is, however your list is here, right? That's the order in which it's gonna go in, however they listed here. So you got this list that you're taking from, and you got this list that you're gonna add it to. And it's gonna go first, second, third, fourth, whatever. It's not gonna try to say, well, oh no, I think he got this int here. I'm gonna put an int down. I think he got a float at the end, I'm gonna add no. Whichever variable in that alignment, that's why it's gonna add it. Okay, so you gotta watch. Another thing to watch is in compiling, and I'm gonna show it to you. In compiling programs with functions, say I do this, I take this out, right? What will happen is I'll get an error, but it will be a link error. So I'm gonna run it. Let's see. Did it run? No, this is not it, huh? No, I said run anyway. I don't want to run it anyway. All right, so I run it. I'm gonna get an error, say no. All right, and if you look down here, let's see. Normally it would say, and I don't see it. But normally what happens if you call, the arguments in the call does not match the arguments in your definition, you'll get an error that say LNK or whatever. That's a link error. It can't link the number of arguments with when it passes them. All right, let me see if I get it here. No. Did I get a link error? No, but I'm saying no, I'm trying to get it to where it does give me that link error. Do that. Okay, got number. I'll take this one. I want to show you what that error is. Okay, let's run it. Okay, let's see. Now, just because I want to get the error, I don't get it. But it tell me about my argument list. Okay, so no, it's not giving it to me. All right, let me do this now. Another way, normally you get a linkage error. If I run the program, this one should run. If I run the program, okay, now I'm not going to input the data, but I'll leave this black screen up. But the compiler, it's working with that. And when I try to debug again, and I have that screen open, did it run? It ran, did it run? Nah, I don't know why. Just because I'm trying to do, let me put it. Okay, let's see. Debug, start without. No, well, it's not. So it's not giving me the error. I'm trying to make it give me the error, and I'm not getting the error. But it would give me a link error because my window is not completely executed. So you have to make sure that the execution of this window is completed, and then start the execution of another file, well, another run. All right. And it tells us how the data meshes up. Passing data by value. And that's basically what we did. We passed the data by value. All right. So if you look here, number is equal to 12. Change me. They're passing 12 to change me. When we go to change me, then my value is 0. Well, really, it's putting the change me into my val, all right? And what it's saying, change me, it's equal to 0. Display here, you're gonna get 0, all right? But when you return back to the main function and you output number, it's not gonna be 0, it's gonna be 12, okay? Now you say, well, Mr. Vesta, why if I pass something to a function and then I change them, it passes into an argument, change the value of that argument, it does not change the value. Well, it's because of the scope, all right? And I'll show you. Let's do this. Say number is 1. I'm gonna output number 1, okay? Well, I'm gonna do something like, I could do it. I'll do like that. Number 1, let's say 1 in compute function. Okay, and what I'll do, I'll output okay, so I'll multiply times 4. All right. Now, but I'm gonna go back here when I get back after compute. I'll say number equal. Let's see. Okay, I'm seeing number. Okay, right. Okay, well, and then I'll just see out number here. All right. Okay, so okay, so now let's just run this and see what happens. So we run it, then I'm gonna explain it. All right, and then we go. All right, so let's say in the main program, number 1 is 500, and I'm gonna add 23. Look what happens. Number multiplied times, what I multiplied it times 4. So let's look. Yeah, see? That's where we get the 2,000. Here we passed what? 500 into number 1 here. So now we outputted number 1 times 4, right? Number 1 in compute function, right? Then we did our total and we outputted the double of, well, it's a double of the number, but that's the total. 500 plus 23, plus 23. Now, let's scroll up. Now what happened? Oh, wait. Number in main function, number 1 in main function. Why is number 1 in main function? Number 1 in main function should have, oh, it is 500. Right. Oh, but I didn't want to even do that. I should have did it like this. That is correct. But let me do number 1 is equal number 1. I could do times equal 4. All right. So, yeah, I'm going to do it this way and print out number 1. So that's going to assign 2,000 to number 1. So I did it in a fashion to where it didn't assign the value. So let's run it again. We get the same answer, but it's going to be a different result. 523. So, right. So here, we got 2,000. You got me? So what happened here, we did number is equal to number times 4. So whatever we got on 500 times 4, we got 2,000. It printed 2,000. But look what happened when we went back to the main function. We went back to the main function, and what? The first number in it was 500. So it's 500. So you say, well, Mrs. Vessel, why did it not change? The reason why it did not change is the scope of number in this function is from main, is only in the main. So whatever the value is 500. I'm taking 500 and I'm passing 500 into number 1 in the compute function. Then I'm changing number 1 to be 2,000 by multiplying it by 4 and storing the value back. But when I return back to the main function, I'm back in the scope of the main, and now it's going to take on the value from that scope. All right? So you got to watch it. In order for me to use the same value, and that's for those, I have to pass it by reference. I'm going to just show you that real quick, and then we're going to go. And like I said, we'll talk about assignment on next class period. What that does, that say pass by reference. Use the address. And like I say, we ain't going to worry about the address, but that's what that's saying. And then I'll have to put this here. All right, here. All right, and that should fit that. So now, what happens now is when I execute this program, it's going to give me, will allow me to input the numbers. I'm going to input 523. It's going to allow the computer to pass 500 to the compute function, multiply it by 4 to get 2,000. But whatever is done to number 1 in the compute function is actually being done to number 1 in the main because it's doing it at its address or at a low level because I told it to use it, pass it by address. All right, so now watch, let's run it. Same exact program, all it did was added the asterisk for the passing it by address. So here we go. So I type in 523. Look what happened. So this time I didn't get 500, right? And then look here. Remember the last time it gave me 523. Well, no, that's right. No, that's right. Because 2,000 plus 23 is this. So now the 2000 here, this is in the main function. But because I passed it by reference using the address, it changed the value at that address location. All right. Any questions? I've been doing all this talking. Y'all been understanding what I'm saying? Hello?
Yes, sir.
All right. So I won't give you an assignment to do. I want you to take this in, read further on the other ways that functions can be used. We're gonna continue on next class period, and hopefully I'll get to some of the I will get to the other ways of doing the functions and whatnot, and then I'll give you an assignment. All right. Okay. Everybody got that?
Yes, sir.
All right. So I'll see y'all on next class period. Read up on your chapters and everything. Right. So keep reading on this chapter. So I'll see y'all on next class period.
Yes,
All
sir.
right.
Have a good one.
All right, y'all have a good one.